All right, we're going to do a few things here today in day 2 of 1.7 with vertex form. I don't know if we have seen this much. I think I might have mentioned it earlier. Not sure. Anyway, this part up here at the top really should say y equals a times x minus h squared plus k. This is the third and final form of a quadratic that we're going to discuss. And we want to do some really similar things with it. But we just got to talk about some of the basics of a quadratic that's in vertex form. These numbers that we see for h and x come in really handy. They are the coordinates for the vertex, okay? Which is, if we're producing graphs, it makes it really, really slick to produce good sketches, because one of the most important points that we need to locate on a quadratic graph would be the vertex. We got to know where that is, and it's very available when it's in vertex form. Axis of symmetry, if you relate it to this, is going to be right at h, because again, that vertical line goes right through the x coordinate of our vertex. One thing we need to be careful with the y-intercept. Plug in x equals 0. Here's what happens quite a bit. In standard form, which is ax squared plus bx plus c, that constant number at the end, c, is the y-intercept. So many times people think that this constant at the end, k, is also the y-intercept, and it's not. Okay, it doesn't work out. It's not the y-intercept, and to convince yourself of that, make note of whatever that value for k is, and then plug in 0 for x and evaluate, and compare the two, and you're going to see they're never the same number. Okay, ever. Plug in 0. That's the best way to go about it. I'll then find a reflection point and produce your sketch. Okay, you'll see we're not talking about new points in the graph. There's just some different ways of finding those points based on a different form of a quadratic. Here we have a quadratic in vertex form. Quite naturally, I would start with finding the vertex. And again, that's the great part about this, is the vertex is at -1, -3. Easy as can be to find that. The axis of symmetry is the vertical line x equals -1. That wasn't too bad. Now be careful here. Don't say the y-intercept is 0, -3, because it's not. Okay? If I plug in 0 for x, okay, that is put in a 0 right there, I get 1 squared, which is 1, times 2 is 2, minus 3 is -1. Okay? Take a minute to pause if you need to crunch through those numbers again. But the y-intercept is -1, because that's what I get. That's what I get when I plug 0 in for x. And notice that it's not the same as the number at the end. Okay, it never is. All right. We got a few other things to get to, so I'm not going to plot the sketch. But understand at this point, all we'd have to do is add a reflection point with the y-intercept. And it's the same. It's the same as standard form and factored form. We just get these key points. But that's how we find them from a vertex that's in, or a quadratic that's in vertex form. We mentioned earlier that completing the square is a technique that we could use to take a quadratic that's in standard form, and we can switch it over to vertex. And I'll take a minute here to run through how we do that. Okay, so this is not, this is nothing different from before when we would complete the square. But I will start by setting this equal to 0. And dividing everything by 6 while making note up here in the top right-hand corner that I divided out a factor of 6. The next step is to add 1/2 to both sides. And at this point, what I'm seeing from most of our work on completing the square, that getting to this point really hasn't been the issue. This is where a lot of us are getting stuck. This is the point where I will refer to the middle term. I will divide it by 2, and I square it, and I get 1, which means I'm going to add 1 as that third and final term to the quadratic on the right side. And of course, that means over on the left side, I need to add 1 as well. That leaves me with 3 over 2 on the left. The reason I chose the number 1 is this will now factor beautifully as x plus 1. And this is actually the point where I am going to take 6 and bring that back. I'm going to multiply everything by 6, and I get 9 equals 6 times x plus 1 squared. Okay? And to finish off the whole process, if I subtract 9 from both sides, I get y equals 6 times x plus 1 squared minus 9. And I've switched that quadratic over to vertex form. Okay, so completing the square isn't just used to find x-intercepts. We've done that previously. But we can also use it to switch to vertex form. Okay, now if I wanted to produce a graph of this in vertex form, it would be just like the slide before. Find your vertex, your axis of symmetry, your y-intercept, and plot your key points. All right, a couple other things that I want to take a peek at here are to come up with the equation of a quadratic if I'm just given a little bit of information. Now this is kind of a tricky one. I know we've mostly been talking about vertex form, but here's another case where I have information about the x-intercepts. And anytime I have info about the x-intercepts, I want you to be thinking factored form. Okay? The fact that I have an x-intercept of -6 means this quadratic has a factor of x plus 6. And it has an x-intercept of 3, means it has a second factor of x minus 3. And really, when you get down to it now, all I'm looking for to get an equation here is what is the value for a? That's the number that stretches the graph vertically and either makes it wider or skinnier. I know the y-intercept is -9, which means that y is -9 when x is 0. That leaves me with one single variable, a, and I'm simplifying the right side here. 6 times -3 is -18. Divide both sides, and I get 1/2. Okay? I could put all of this together, the fact that a is a half, I have a factor of 6, and I have a second factor of -3, and I actually have the equation of the quadratic that has those properties, that has a y-intercept of -9 and x-intercepts of -6 and 3. If I wanted to switch this over into standard form, it would just be a matter of foiling and changing this to standard form, which I'm not going to do right now because you've got plenty of practice so far this unit with foiling, but that's all it would take to switch it to standard form. Okay. The key here, though, is any time that you see a reference to x-intercepts, you should be associating that with the quadratic's factored form. Well, matter of fact, hold on a second. I think I jumped the gun there, saying we were done. Apologize for that. I did not see we have one slide left. Doing the same thing to put ours in vertex form. Sorry about that. Here, the process here is going to be really similar to find the equation. What's going to be a little bit different is I'm going to use a different form. Okay. Here, this tells me the minimum value, which makes me think vertex. The minimum value, assuming this quadratic opens up, is the vertex. What I'd have here is still an unknown quantity for A, but the vertex is negative 1, 4, which tells me this is x plus 1 squared minus 4. Okay, because again, hk is the coordinates of the vertex, so I plugged in negative 1 for h, plugged in negative 4 for k. Now it also told me a second point, which was when x is 2, y is negative 1. Okay, just like the previous example, all that's missing is a, and negative 1 equals a times 9. I got that from 2 plus 1 squared. Adding 4 to both sides, I get 3 equals 9 times a. Dividing by 9, I get that a is 3/9, or 1/3. Okay? Now, if I wanted to write my final answer here, in vertex form, a is 1/3, which makes this graph wider. And the vertex is at negative 1, negative 4, which means I will write this as x plus 1 squared minus 4. Okay? And there is the equation for my quadratic in vertex form. Okay? And just like the previous one where I used factored form because I had x-intercepts, the key for me here was to recognize that this referred to a minimum value, which means one of the points they gave me was the vertex. That was my sign to use vertex form. Okay? When we have x-intercepts, think factored form. Vertex, think vertex form. That's why we're going over this form of a quadratic, because it works really well for these types of cases if you have information about the vertex. And it's not like we can't get to the other forms. If I wanted to take this and get to standard, okay, remember standard is ax squared plus bx plus c. Okay, it's just a matter of foiling, okay, expanding to get to standard form, which we could certainly do. All right, that's all for 1.7, day 2. For real this time, that's all. And if you have any questions, bring those to class and we'll discuss them more. This leads us to 1.8, day 1. We're going to be getting into quadratic models, some real-life applications and whatnot. And we'll call it quits right there for 1.7, day 2. And we'll resume in our next lesson with the first day of 1.8.